Good evening, learners. My name once again is Mr. Pochilola, your teacher on this platform. Let me welcome you to this revision series in which we continue looking at past exam papers. This is physics paper. In 2022. Welcome. This is paper 1. Physics paper 1. As usual, I encourage my students to know the structure of your paper. So this is paper 1, physics paper 1, which carries 100 marks. Alright, so when you are writing physics paper 1 in your 2026 Msce exams, you have to know that your paper 1 carries 100 marks, a total of 100 marks, and that it has 2 sections, namely section A and B. Physics chemistry paper has 2 sections, sections A and B. Section A has 10 questions, demanding short answers, while section B requires that you should write essay questions, that you write and you'll be required to answer all the 13 questions. So altogether there are 13 questions. A has 10 questions, carrying 70 marks, and section B has 3 questions, each carrying 10 marks, a total of 30 marks. Alright. You are allowed to use a calculator in paper 1. Okay. So you are allowed to use the calculator. When you finish the writing, you'll be required to tick against the questions that you have answered. Let's suppose you answered question 1 very well. Okay, so you tick that. You answered question 2. For some reason, you did not answer question 3, so you use this graph. For some reason again, you didn't answer question number 4. You answered 5. You answered question 8. So make sure you tick those questions which you have answered. Tick in these boxes to show that you have answered these questions. But for some reason, if you skip question number 12, you leave that blank, so don't tick, and you go on to question 13. Alright, but if you happen to answer all the questions, why not? Tick all of them. Tick all the questions. I would encourage you to attempt all the questions so that you maximize the number of marks scored. Alright. And you are told not to write in these sections, so don't write in these columns. Don't write anything there. This is for recording marks. When your paper is being marked, the examiners will record marks in these columns. Let's say question 1, you got 2 marks, so the examiner writes 2 marks there. Question 2, maybe you didn't get any marks, be too bad. So the examiner will write 0 there to show that he did not score any marks there. And he got 3 marks in question number 3, and so on. Alright, this column is not for the markers, it is for the senior examiners. The senior examiners are the teachers who check already marked scripts if they have been marked according to the standard, according to the requirement. Alright, so if the senior examiners remarked the paper and got a different mark, let's say after remarking, the senior examiner found 1 for question number 1, so we write 1 there, and or maybe after remarking question 2, the senior examiner found that the mark is supposed to be 2. So they will write in these columns with a different ink, usually green or something else. Alright, so that's your paper structure. Once again, you are welcome to this revision. So let me invite all the 2026 Msce candidates to gather here so that we can revise this paper together. Alright, we try as much as possible to look at a good number of questions. Then we are going to break and continue later. So once again, without wasting your time, welcome to section 1, section A, which carries 70 marks, and you are told to answer all questions in this section. Question number 1A. Figure 1 is a graph which was plotted after conducting an experiment in which different masses were hung from the end of a spring head on a stand to find extension of the spring. Alright, so this graph is as a result of an experiment that was carried out. Okay, remember, let me just remind you what we mean by extension. Alright, so when you hang a spring on a stand, the length of the spring is called unstretched length. Unstretched length or original length. Now when you hang a mass to it, its length is going to increase. Alright, and this new length is called stretched length. So when you subtract the stretched length minus the unstretched length or the original length, you get what is called extension. So extension is the stretched length minus the unstretched length. Yeah, so this is from a Form 4 topic called the Hooke's Law, which I'm sure you will have covered by the time you are taking your exam. You have covered this topic very well. So we have extension. Extension values are plotted on the y-axis. So we have the extension here, all right, while mass is plotted on the x-axis. In other words, mass in this case is the independent variable. And the extension is the dependent variable. All right, remember, the rule of plotting graphs is that unless otherwise stated, The independent variable is plotted on the x-axis, while the dependent variable is placed on the y-axis. Independent on the x-axis, yes, or horizontal axis, while the dependent variable on the y-axis. All right, so we have here the line of best fit, which is plotted. I'm sure you can see the points. Let me zoom in a bit. Yeah, so we have the points, the plotted points. We have a point here, we have another point there, we have another point there, another point here. All right, I think we have 5 points were used. Of course, you have 2 that are lying out of the line. All right. Yes. All right. I'm sure you can see that clearly. Okay, to produce this graph, so these points were used. Okay. So let's look at the questions. The questions are saying, Roman numeral 1 here is saying state the relationship between extension and the mass shown by the graph, the relationship. All right, so for us to tell the relationship, we have to look at the shape of the graph line. Okay, so this is a straight line. A straight line usually depicts a direct relationship. Okay, so since it's a straight line, you'll say that extension is directly proportional. Extension is directly proportional. Is directly proportional to mass. Yeah, so that's the relationship. Okay, meaning that as mass increases, extension also increases. As mass increases, extension also increases. That's a direct relationship. So you can also say, as mass increases, extension also increases. That is also a relationship. Okay. Right. Roman numeral 2, question Roman numeral 2 requires us to find the extension on the spring when 400 grams mass is hung on the spring. All right, so what is the extension when the mass is 400? Okay, so all we have to do is go back to the graph, go on the x-axis to the point where the mass is 400. So mass is 400 right here. So mass is 400 right here. So all we have to do now is to go up along that line to the point where you touch the graph line. All right, so the line touches the graph line somewhere here, over there, and then you go across to find the corresponding extension, just to go across. All right, so this point is roughly 8.2. All right, so take note, it's 8.2. So 400 grams produces an extension of 8.2. Okay, convince yourselves that this point indeed corresponds to 8.2. Yeah, because once you get there and you go across like this horizontally, yeah, here you'll get 8.2. the corresponding value there is 8.2. So 400 grams produces an extension of 8.2. All right, that's very beautiful. So we have 8.2. Don't forget the units of extension. Extension is in centimeters. So indicate this is 8.2 centimeters. All right, so that's what we have. Unless you have a question, don't forget, if you have any question, leave your question in the comment section below, or simply reach out to me on the number shared earlier on. All right, still referring to the graph, we are asked to derive the unit of the slope, the unit of the slope of the graph. All right, so we go back to the graph. Remember, slope is simply the change in y-axis. So in this case, we shall take the change in extension, and this side, the change in mass. Yeah, so slope is going to be, therefore slope is going to be the change in extension divided by the change in mass. So extension is in centimeters, while mass is in grams. Therefore, the unit of the slope is going to be centimeters per gram. Centimeters per gram. All right, so that's what we have. So take note, centimeters per gram. Don't do the opposite. Don't do the opposite. Some may, for some reason, do the opposite. They will say slope is equal to change in mass divided by change in extension. This will give you a different unit of gram per per centimeter, which is wrong, because by definition slope is the change in y. Slope is change in y divided by change in x. So y is extension and the x is the mass. So you're dividing the change in extension by the change in mass, and the extension is in centimeters, mass is in grams. Therefore, the unit of slope is going to be centimeters per gram. Centimeters per gram. All right, that's what we have. Okay, so simply transfer that. What we got there, here it will be centimeter per gram, which is also written as centimeter like this, then g to the power minus 1. It's the same, right? It's the same. All right. And Roman numeral 4, give a reason for the points lying outside the graph. Okay, let's go back to the graph. All these things are coming from the graph. The questions are coming from the graph. So let's clean it up so that we can see our graph clearly. All right, so let's do the cleaning up so that we can see the points that are lying on the graph. We're going to see the points clearly and use them to answer our question. All right, once again, if I zoom this in, you should be able to see the points. Okay, so our points here are, we have a point here, we have another point there. These 2 points are lying on the line. We have another point here. So these 3 points are lying on the line. Okay, but if you look at these 2 points, these 2 points are outside. This one is out, this one too is out. So what do these indicate? What do these points lying outside mean? So these 2 points are basically due to random errors. These are due to random errors. Remember, random errors are the errors in an experiment that keep fluctuating, that keep changing, all right, that keep changing in the experiment. So they would cause some values to lie out, okay, out of the other values. All right, so only the first 3 points are on the line, while these others, which I've circled in red, are outside to signify that, or to indicate that there are some random errors in the determination of the extension. All right, so go back to the questions. We are asked to say, give a reason for the points lying outside the graph line. Okay, so here we just have to say they are due to, this is due to random errors in an experiment. All right, let me urge you to go back and revise your notes on errors, types of errors, such as systematic errors and what causes them, parallax errors, and other errors, types of errors. Go back and revise. Give the reason for repeating an experiment and taking an average of the results. All right, so the reason why it is essential to repeat an experiment and take an average of the results is to minimize random errors. To minimize random errors. To minimize random errors. Random errors are the only type of errors that can be minimized by repeating the experiment and averaging the results. This cannot be used to eliminate systematic errors. Systematic errors are always inherent in the experiment because they are due to the instrument being used. So they cannot be eliminated by repetition of the experiment and averaging of the values. It's only random errors that can be minimized by repeating the experiment and averaging the results. All right, I hope so far so good. If you have not subscribed to the channel, if this is your first time to visit the channel, consider subscribing so that you don't miss our future revisions. And also remember to hit the notification bell. Part C, give any two factors that can affect the speed of sound in air. All right, so speed of sound in air can be affected by a number of factors. Can be affected by humidity of air. Humidity of air. The higher the humidity of air, the lower would be the speed of sound. All right, can also be affected by direction of wind. Direction of wind or windy direction. The windy direction, humidity of air, can also be affected by distance from the source. Distance from the source of sound. The longer the distance from the source of sound, the lower would be the speed of sound. Direction of wind. Okay, if the wind is blowing in the direction of the sound is going to travel faster. All right, so these are just some factors that affect the speed of sound in air. All right. So that's good. Give any two effects of unusual expansion of water. Remember, unusual expansion, which is also called anomalous expansion of water, is the unusual behavior of water. Water expands when cooled below 4 degrees Celsius and contracts when heated slightly above 4 degrees Celsius. That's called unusual expansion, also known as anomalous expansion. So, the unusual expansion of water has a number of effects. Alright, one of them is bursting of pipes. Bursting of pipes. Bursting of pipes. When water is cooled below 4 degrees Celsius, it's going to expand. So if the water is in a pipe, the pipe is going to burst. Okay. Another factor, another effect is the breaking of rocks, which is called weathering. Breaking of rocks. Right, when the water accumulates between the cracks of a rock and is cooled, it's going to push the pieces of rock apart, causing breaking, which is also called weathering. All right. It would also cause freezing of lakes. Freezing. Okay, another effect is the freezing of lakes. Okay, no problems, since they're asking for only two, so the ones we stated earlier are just as good. Bursting of pipes, breaking of rocks. All right. Number B, 2B, state Archimedes principle. Archimedes principle. Okay, Archimedes principle is about objects being immersed, partly or fully immersed in liquids. All right, so Archimedes principle states that a body which is fully immersed, fully or partially, immersed in a fluid, experiences an upthrust. Experiences an upthrust or a force, upward force, which is equal to the weight of the displaced fluid. Sorry, this has overflowed down here because of the limited space. My handwriting is too huge to fit into this given space. All right, so state Archimedes principle once again. A body which is fully or partially immersed in a fluid experiences an upthrust which is equal to the weight of the displaced fluid. Please take note. Don't confuse this with the law of flotation. The law of flotation states that a floating body displaces a liquid or a fluid a floating body displaces its own weight. All right, displaces its own weight. Okay, so don't confuse the law of flotation with Archimedes' principle. Archimedes' principle is about a body which is either fully or partially immersed in a fluid. It is going to experience an upthrust equal to weight of the displaced fluid. All right, so that's the principle called the Archimedes' principle. I hope you have taken note of that. All right. Once again, my name is Mr. Pochilola. In case this is the first time you have visited the channel, consider subscribing to the channel. All right, so let's create space for the last part down here. Okay. Calculate the upthrust. Okay. Calculate the upthrust force on the stone that has a mass of 60 kgs and weighs 40 newtons in water. All right. First, you must understand the definition of upthrust. Upthrust is simply the difference between the weight of the object in air and the weight of the object in a liquid. In this case, we're looking at water. All right, so we have to find the weight in air. In order to find weight in air, we simply take 60 kgs, the given 60 kgs multiplied by 10. This is going to give us weight in air. Remember, 10 is known as the gravitational constant. 1 kg of anything is the same as 10 newtons. Therefore, 60 kgs is going to be 60 times 10. All right, 60 times 10. And we are told that the same object weighs 40 newtons, so we subtract 40 newtons. All right, so in this case, we shall have 60 times 10, which is 600. 600 newtons minus 40 newtons. Okay, so subtracting this will give us 560 newtons. Please verify. We have 60 times 10, which is 600. Right, from this we are subtracting 40, which gives us 560 newtons. This looks so huge for upthrust, but that's okay because that's what we are given in the statement. Yeah, so that's the way to go. And also remember that this is what is known as apparent loss in weight. Apparent loss in weight. Loss in weight, apparent. So upthrust is also equal to apparent loss in weight. It's the difference between the weight of the body in air and the weight in water. Weight in air minus weight in liquid. In this case, the liquid we are looking at is water. We are told it's water here. All right, so that's it. In case you have a question, don't hesitate to come back with a question, then we'll look at it together and rectify. And in case I've not explained properly what I was supposed to have explained, don't hesitate to come back and seek clarification. It is going to gladden my heart. It will gladden my heart to re-explain what I have not explained in the first place. Welcome, learners. Please invite your friends to this channel so that they can also revise with us together. And you are also free to share this video to your friends, wherever they are. Invite them to join us, to subscribe to the channel so that they too can revise with us. All right, number 3, Give any two dangers of radioactive substances. All right, radioactive substances, if not handled properly, have dangerous effects on humans as well as on the environment. All right. So, since the question is asking for just two effects, two dangers, okay, if not handled properly, exposure to radioactive substances can cause cancer, can cause gene mutation, any of these, gene mutation, but also it can cause defects. It can cause defects to unborn babies, Can cause defects to unborn babies. It can cause headaches. Can cause headache. Can cause many other factors. All right. It can lead to crop damage. Can lead to crop damage and many other effects or dangers. All right. So since they're just asking for two, you can select any two from this and present. All right, let me ask you also to revisit your notes so that you can state as many effects or dangers of radioactive substances. Number B, figure table below shows radioactive isotopes and their half-lives. Remember, half-life is just the time taken for half of the radioactive substance to decay or to decompose. So it's time taken for half of the radioactive substance to decompose. All right. So using the table, which isotope is ideal to be used as a tracer in medicine? Usually, radiations to be or isotopes to be used as tracers must have a short half-life. So all we have to do is look for the isotope that has the shortest half-life. Carbon has 5,600 years, that's too long. Calcium has 30 years. Iodine has 8 days. Sodium has 15 hours. All right, so in this case, it is iodine. Iodine because it has the shortest half-life. It has the shortest half-life. So tracers usually should have shortest half-life so that they don't have any bad effects after they have been used on a human body. So in 8 days time, they have all decomposed or disintegrated, and in so doing, they will have no further effects on the patient on which it is used. All right. So iodine has the shortest half-life, therefore it is the best choice. All right. Number C, calculate the amount of current introduced in the primary coil of a 100% efficient transformer if it converts 400 volts to 200 volts in order to operate a 500 amp hair dryer. All right. So for a transformer which is 100% efficient, usually power input, just say power in, must be equal to power out. Okay. Power for a 100% efficient transformer, power input must be equal to power output. So go back to the definition of power. Power is voltage multiplied by current. In this case, voltage in primary coil multiplied by current in primary coil is equal to voltage in secondary coil multiplied by current in secondary coil. The rest is just substitution. So we are told that voltage in secondary coil is 400. So we have 400 volts multiplied by current. This is the one we need to find. And the voltage in secondary coil is 200. So we have 200 multiplied by current, which is 5. Yeah, so the rest is just mathematics. So we have 400 IP is equal to 1000, I think. Yeah, 200 times 5, 200 times 5 is supposed to be 1000, yes. Then next you divide both sides to find IP, which is the current that they are requesting us to find. Divide both sides by 400. Divide both sides by 400. So the current, therefore, in primary coil is going to be 1000 divided by 200. Excuse me. It's supposed to be 1000 divided by 200. Huh? No, divide by 400. Divided by 400. It's supposed to be 2.5. So the current is going to be 2.5 ampere. Don't forget the units. Yeah, so that's how to go about this one. In case you have questions, don't hesitate to reach out to me on the numbers that I shared earlier on so that we can discuss. You can look at the possible solutions. Question number 4. Welcome to number 4. So far, so good. Question number 4, figure 2. This is question number 4b. Figure 2, which is this one here, is a diagram of a wave. All right, so we have this diagram here of a wave. Okay. All right. Okay. We are asked to name the type of wave shown. So this is a longitudinal wave. Longitudinal. Remember, a longitudinal wave is one in which the particles vibrate in the direction parallel to the direction of the propagation of a wave. All right, so the particles are vibrating in parallel or in the same direction as, or rather I would rather use the word parallel to the direction of the wave. So the wave is going this way, and the particles are also vibrating along the same direction. Okay, so that's typical of a parallel, a longitudinal wave. Okay, so calculate the wavelength. Calculate the wavelength of the wave. All right, so for us to calculate the wavelength, we need to find how many wavelengths we have in this wave. So we have one, that's the first one. We have another one, 2, and then we have another one, 3. So we have 3 wavelengths here. Okay, for which 3 wavelengths is equal to 9 centimeters. 9 centimeters, so to find one wavelength, you simply divide both sides by 3. Okay, so therefore the wavelength is simply equal to 3 centimeters. That's all. That is it. All right. In case you are not sure, please reach out to me so that we can rectify what you might have must have missed. All right, so we have 1 mark for saying that, 1 mark for this, a total of 2 marks. Yeah. Great. Explain how the length of the let's go back a bit. Have we answered everything? Okay, down here there's also a question. Normal number 3. Calculate the wave speed given that the wave has a frequency of 0.5. Okay, wave speed v is given as frequency multiplied by wavelength. Make sure you know this equation. Wave speed is equal to frequency times wavelength. So frequency is given to us as 0.5, and wavelength we just found it is 3. All right, so therefore the speed is going to be, all you have to do is 0.5 multiplied by 3, which is 1.5. All right, so this wave is traveling at a speed of 1.5 meters per second. All right. By the way, this is supposed to be centimeters, because yeah, because we're multiplying by the distance, the wavelength is in centimeters, so we have 0.5 times 3 centimeters, which is 1.5 centimeters per second. Yes, that's what we have. All right. Number 5. Before we go to break, explain how the length of an inclined plane affects the mechanical advantage of the plane. All right, so remember, mechanical advantage, MA, is load of the object divided by the force being applied, which is called effort. All right, so let's suppose in one case we have the length is this one here, and let's suppose we have a body over there. This is our load, and then we have another setup where the length is a bit longer. If the length is longer, it means that you are going to apply less effort. You will have to struggle here. You have to struggle here to exert greater force to get the object to the top there. But here, where the length is a bit longer, it is going to slant. It's going to be more slanted than it is in this case. Therefore, you exert less, you require less effort. So when the effort is less, what it means is that mechanical advantage is going to be greater. All right, so explain how the length of an inclined plane affects the mechanical advantage. All right, so what do you have to say here? 3 marks. Okay, so when let's put it like this. When the length increases, that's 1 mark. Effort decreases. Another mark. And therefore, mechanical advantage increases. Yeah, another mark. So you have 3 marks for saying all these points. All right. I hope so far so good. Let's go down before we go to break. Figure below shows a block with 2 forces acting on either directions at 30 centimeters. Use it to answer the questions that fall. Assuming the surface is frictionless, calculate the resultant force if the block is moving horizontally on the surface. All right, so here we have 2 forces. We have this force here, 25, acting at an angle of 30. So we need to find the horizontal force to the right. Let's just call this force to the right. And there's another force acting in the opposite direction. Let's call the horizontal component for this force to the left. So to find the resultant force, the force that causes the body to move, this resultant force, let me use a small arrow here to show right, and a small L, yeah, for left. Okay, so F of R is the resultant force. It's going to be equal to the 25 Newton force multiplied by the cosine of 30 degrees. Remember, to find the horizontal component, you take cosine of it multiplied by the given force, subtract, maybe in terms of the given symbols there, it is going to be equal to horizontal force to the right minus horizontal force to the left. Okay, better. This is better. All right. So in this case, we shall have 25 newtons multiplied by cos of 30 degrees minus 20 newtons multiplied by cos of 30 degrees again. All right, so the rest now is mathematics. So in this case, we shall have 25 times 0.86, I think, minus 20 multiplied by 0.86 again. Just be sure, what's cosine of 30? Cosine of 30 degrees is 0.66, yeah. So we have a 6 there, we have a 6 here. So in this case, 0.866 times 25 is giving us 21.65. This is 21.65. 21.65 minus 20 times 0, 20 times 0.866 is 17.32. 17.32. All right, so therefore the resultant will be 21.65 minus 17.32, which is equal to 4.33. So the resultant force is 4.33 newtons. Okay, so that's what we have. All right, I would like us to break now. Then we come back later to continue with the rest of the questions. Once again, my name is Mr. Pochlola, your teacher on this platform. Don't hesitate to subscribe to the channel so that every time I upload a new video, you become first one to know. Bye-bye for now. Work hard.